Hello, I am about to start working the 2023 AP Calculus free response questions, and I have not read them yet. I always, when I record me solving them for the first time, I always like to record myself reading them, and so you can kind of see me problem solving the problems or the questions as I run into them. So every now and then I may hit a little hiccup and have to think for a minute. But this one is a calculator question, so I have my trusty TI Inspire ready to go. So let's look at number one here. Let me scroll down. Okay, so we have a table. Customers at a gas station pumping gas into a tank. The flow of gasoline is modeled by the differentiable function f. Therefore, f is continuous. I'm going to go ahead and write that right now. And to speed things up, I'm going to type some of these little statements. So I'm going to say f is differentiable. Therefore, f is continuous. You need that little qualifier in case they ask a theorems question or something like that. F is modeled in gallons per second. T is measured in seconds since pumping began. And F is given in the table. Okay, use correct units to interpret the meaning of this guy. Okay, so for part A, the question is asking about the antiderivative from 60 to 135 of f of t dt. And so we're finding a definite integral of the flow. F of t is measured in gallons per second. Dt is representative of a small change in time, which we measured in seconds. And when you multiply f of t times dt, you are left with only gallons. And so the units are gallons, and this antiderivative represents the number of gallons that the rate of flow of gasoline doesn't tell you where it's flowing. I mean, you obviously assume, oh, pumping gas. Okay, there is pumping gas into a tank. Okay, so this represents, and again, I'm going to type this for the sake of time. So this antiderivative represents the total number of gallons pumped into the customer's tank from t equals 0 seconds to t equals 60. Oh, whoa, I need to go back. This is not 0. It's going from 60 to 135. So pay attention to stuff like that. Common mistake. The table goes from 0 to 150, but we're only looking at a small section of it. So there is the interpretation of the integral. And then it says use a right Riemann sum to approximate this. So right Riemann sum, we need the delta x's for the heights, or for the bases of the rectangles, and the function values for the heights. So from 60 to 90 is a base of 30, and we're using the height on the right side, which is 0.15, plus my next interval from 90 to 120 also has a base of 30 and a height of the function value at 120, which is going to be 0.1. And then 120 to 135 has a base of 15 and a height, which is the function value at 135, is 0.05. And you can stop there. I am going to go ahead and throw this in my calculator because we may end up needing this answer later. So to my calculator I go, and I need to do 30 times 0.15, 30 times 0.15 plus 30 times 0.1. Whoops. Oh, geez. What am I doing? Plus, and then 15 times 0.05. And always double check that you plug everything in there correctly. 30 times 0.1, 15 times 0.05. I think I did. And I'm getting 8.25 gallons would have been pumped. Now, I'm not going to include units right here. That is in gallons. Oh, what the heck? I'll go ahead and write gallons. So that's how many gallons were actually pumped into the tank. And a piece of advice is when you simplify things as unnecessary, I'm going to draw just a quick line through that, just in case I made a little mistake. And that way an AP reader would not be tempted to, or wouldn't read that answer, just in case you made a mistake. The unsimplified version is correct. And in the case of Riemann sums, you do want to show something that represents both the bases and the heights. Don't go straight to whatever these products are. Show three separate products, and I'll leave it like that. Part B is a mean value theorem question. Must there exist a value C for 60 to 120 such that f prime of C is 0? And so I'm going to bring this down here because this is the part. Let go. My mouse is sticky here. Let go. There we go. So this is the part where you need that qualifier. F is differentiable, therefore continuous. I'm going to move all of this stuff up a little bit. Okay, so we're trying to prove that the derivative is equal to 0. This sounds like a good old Rolle's theorem question, and it is, because if you look at the table, f of 60 is equal to f of 120, and they both equal 0.1. That last little bit's not necessarily necessary. Therefore, Rolle's theorem, which I always tell my students not to name theorems because you're volunteering information that's not specifically requested. But this is Rolle's theorem, guarantees that f prime of, and they do use the letter C, is equal to 0 for some C on the interval, and we're going from 60 to 20. So that was a very, so far this is an extremely nice question. Very typical. The rate of flow can also be modeled by G of T equals this mess. So at this point, I go to my calculator and I can define G of T to equal that ugliness, and that is ugly indeed. So not control enter, stupid. Let's go back. I want to control divide. I'm going to save this in my calculator. That's T over 500 times the cosine of the quantity of T over 120. And I need to square that, double checking that that is in there correctly. T over 500 cosine T over 20 squared. That is good. That is now defined. Also, there's a trig function, so make sure you are in radian mode, which I am. So 150, find the average rate of, oh my gosh, this is such a nice question. So nice, so nice. If you had form O, you should be happy. You should love these questions. They give you a function that is the rate, and then they ask for the average rate. We want the average of the function given. This is the average value theorem. So it's 1 over 150 minus 0, antiderivative 0, 150 of that rate, which is G of T. Simply write that down. They do, I assume, ask you to actually find the answer. Yes. Okay, so then we go to the calculator and we simply punch that in. So control, divide, 1 over 150, and then it's the antiderivative from 0 to 150 of G of T dt. Make sure I did that correctly. It is 0 to 150. Yes. Enter. And stupid answer. Control enter. Let's get that decimal. And I'm getting 0.09599. So this is 0.09599, which you can round to 0.096, or you can truncate to 0.095. You must go to that third decimal. You also have the option, like you can stop right there. You don't have to stop at 3 decimals. You can include more. And finally, use the model G defined in part C to find the value of G prime of 140, and then interpret wow, this question is as nice as they could have started with. That is a very nice question number 1. We need G prime of 140. This is a calculator active question. So I'm going to go straight to my calculator and use the derivative at a point command. Menu, calculus, derivative at a point. I want to plug, I guess I'll swap to t since g is a function of t, 140 into the first derivative of the function g of t. And I'm going to go ahead and hit control enter to force that decimal. So g prime of t is negative 0.0049, which you can write as negative 0.005 or negative 0.004. They do ask for an interpretation. So I try to keep my interpretations as straightforward as possible. G prime was a negative value. That means that the function of G will be decreasing. So my interpretation is essentially that the function G decreases, but we have to be a little bit more specific. We have to specifically say what G represents. So instead of saying G is decreasing, I'm going to put in words what G is, and G is the rate of flow of gasoline is decreasing at the rate of, and the rate of 0.0049. Now, because I have the word decreasing in my explanation, I am not putting a negative in front of that value. If you want to say the rate of flow is changing at the rate of negative 0.0049, you can do that. So let's see, the rate of flow is decreasing at the rate of 0.0049. And because I did the derivative of the rate, this would be in gallons per second. I need to move my head out of the way. Second, actually, I'll just return second per second. There's 2 units of seconds, so it's kind of like an acceleration unit here. And then you want to specify that we are looking at the time t equals 140. Is decreasing at the rate at time t equals 140 seconds. There is your interpretation, and I assume that's it. Let me scroll down, make sure it's not a part E. I can't remember the last time they asked an E, and they didn't. So there is question number 1. Very nice, straightforward question for you. No surprises, no curveballs. And I'm going to have to edit that a little bit because I accidentally flashed my email up there for a second. So anyway, this was a nice question, and hopefully you all got a good chunk of points on number 1 here.